Hi, in this video we have another example related to RC circuits. In this circuit shown, the internal resistance of the battery is 0.1 ohm and the capacitors are initially uncharged. Okay? Calculate the current in ampere flowing in the 6 ohm resistor an instant after the switch is closed. Okay? Then the first time constant, the maximum charge, and at the end the charge stored in the capacitor at time equal 15 microseconds. Okay, now the definition of an RC circuit means we only have one resistor and one capacitor in a circuit. So this required from us to calculate the equivalent resistor of this circuit, and in this case that will be the R equivalent. It will be 2 plus 6, and that will give me 8 ohm because they are connected in series. Now to find the current, we know that the current will be the voltage divided by the total resistance, and it's 20 divided by 8. That will give us, just make sure, it's 2.5 ampere. That's the total current going through the circuit, and we can also call it the maximum current going through all this circuit. So that's part 1 or part A. For the second part of this question, asking you to find or to calculate the first time constant, will tau equal RC. Now again, you will be asked to use the equivalent resistance and same the equivalent capacitance. So these two capacitors are connected in series, so we can do that here on the side. So C equivalent will be C1 times C2, all right, and C1 plus C2. Quickly, we have 5, so that will give us 2.5 microfarad. So we can go back now here and say, all right, I have 8 ohm times 2.5, 10 to the power minus 6, and this will give me back my 20 microseconds as the first time constant for this circuit. All right, now he's asking me to find the maximum charge can be stored in this capacitor. So number 3, the Q max will be the C equivalent, the maximum charge will be stored in these two capacitors times the voltage. So we have 2.5 10 to the power minus 6, and the voltage across the battery was 20. That will give us 50 microcoulomb. The total charge will be stored in the C equivalent in this circuit. For the last part, which is asking me to calculate or find the charge stored in the capacitor at 15 microsecond. Here we go, we have Q as a function of time of 15 microseconds equal maximum charge 1 minus raised to the power T over RC. Now maximum charge is 50 10 to the power minus 6. Here 1 minus exponential, it's 15 micro divided on 20, also micro, so micro with micro will cancel each other, and that will give us Okay, that will give us total of 26.38 microcoulomb. That's how much charge will be stored after 15 seconds from connecting these two capacitors with the battery, and it will be still rising to reach the maximum 50 microcoulomb. All right, so I hope you see how we can handle a question like this. Remember, when we talk about an RC circuit, it's not about dealing with them separately. No, we have to have only one resistor and one capacitor. So you could apply the rules you learned before about resistors in series parallel or capacitors in series or parallel. And then you find the equivalent and apply it for finding maybe the maximum current or the time constant or the total charge stored in a capacitor. All right. I hope you find this example useful and see you in another one. Thank you.